Hello and welcome to the final part of the Remove Forcing Exam Give Back 2015 with me, Mr. Norman. This is the final question, which we've already said on the end of the previous video was pretty hard. We're asked to draw a velocity time graph for the velocity of car B relative to car A. So that's as observed by the driver of car A. Now, first of all, let's just draw the velocity of the two cars separately. So minus 20, minus 30, minus 40. So we're told that for car A, it accelerates at 2 meters per second squared for 10 seconds. That means in the first 10 seconds, 2 meters per second squared for each of those. So therefore, it's going to reach a speed of 20 meters per second in the first 10 seconds. So there we go, that's car A. Then it goes 0 meters per second for 40 seconds, so not accelerating or decelerating. Its velocity is going to stay the same, 10, 20, 30, 40 seconds. And then finally, minus 1 meter per second for 10 seconds. So it's going to go down by 10 meters per second in total. So it's going to go down to there. So this is the velocity time graph for car A. Now let's use a different colour to do car B. So car B, we're told that it goes at 2 meters per second squared for 20 seconds. So it's going to go up here, and then it's going to carry on for an extra 10 seconds. It's going to reach a final velocity of 40 meters per second. Then it goes at 0 meters per second squared for 10 seconds. Then it goes at minus 3 meters per second squared for 10 seconds. It's going to go down there by 30 meters per second. And then it's got 0 meters per second squared for 20 meters per second. Now, what we're then asked to do is to do the relative velocity. So velocity of car B relative to car A. So in fact, in the first few seconds of this journey, neither of the cars is actually going to be moving at all relative to each other, because they're both going to be sort of level pegging. So in the first 10 seconds, nothing happens. Now, in the next 10 seconds, this car stays where it is with respect to the other car, but this one pulls ahead. So in fact, we're asked to do the sort of difference between these two cars. So in this second, how far ahead does it pull? Well, we want to know what is this sort of speed underneath here. So in fact, it's going to be 20 meters per second sort of pulling ahead. Then in the next meter per second, neither of the speeds changes. So this one's going at 40 meters per second, and this one's going at 20 meters per second. So although this one is getting further away, in terms of relative velocity, this one's going to be moving further away at 20 meters per second. So in this case, this is going to stay level. Then finally, this is going to sort of decrease, and it's going to go down to 0 at this point here. So the relative velocities is going to go to 0 at that point, and then it's going to go down, and it's going to go down to minus 10, so down to minus 10 there. So we're sort of taking away the red line from the black line, really. Then it's not going to change, so the difference is going to be 10 in the velocities. The relative velocity is going to be 10, and then finally it shrinks down to be 0 at the end. So our final velocity time diagram for both of them is going to be the green line. Now, lots of people, of course, just did the green line. So if you're going to do it using a slightly different scale here, it might have looked, in fact, something like this for your final answer. Notice my scale on this second graph is slightly different. I'm going to go down to minus 10 here, and then across, and then back to 0. Now, the key thing with this was that I really tried to give you some marks for working if you'd shown it. So 2 meters per second for 10 seconds, that gives us a final speed of 20 meters per second. 0 meters per second for 40 seconds, that's not going to change our velocity, so it's still going to be 20 meters per second. Minus 1 for 10 seconds, that's going to go down to 10. And if you showed working here, I really tried to give you some marks for the working. Now, using the graph, calculate the separation of the cars after 60 seconds. So the separation of the cars, the final separation, is going to be the area under this bit. So let's call that area A. Take away this area here, which is below the line. So that's going to be called area B. So the final speed here, area A, take away area B. Area A, we can see, is made up of 3 bits. We've got the central rectangle, plus sort of 2 triangles here at either end. So area A is actually made up of 3 bits. And then we're going to take off area B, which is also made up of 3 bits. Now, if you do the calculations, half base times height, so the first triangle, a half times 10, and the height is 20, plus the rectangle, so that's 10 times 20, plus the remaining triangle, so that's actually, so it hits the x-axis 2/3 of the way along, so we've got 6 2/3 times by 20. And then we're going to take away from that all of the rest of the area. So that is going to be area B. So we've got 3 1/3 times by 10 plus 10 times by 10 plus 10 times by 10 times a half, because it's a triangle, a half base times height. So if you work all of these areas out, we've got a half times, so 10 20s, that's 200 times a half, so that's 100, plus 10 20s, that's plus 200, plus 20 times 6, that's 120, plus another 2/3 of 20, so that's going to be 133 1/3. Take off 3 1/3 times 10, so that's 33 1/3, plus 10 times 10, which is 100, plus 100 is plus 50. So if I add all of these things up, so I've got, well, 100 to take away 100, so that's going to cancel. 33 1/3, take away 33 1/3, so that's just going to leave me with 100 up here. And then that 100 take away 50, there's going to be 50 there, so that gives me a final answer of 250 meters.